Students, in the today's class we are going to start with a new chapter, that is electrochemistry. Okay, so what is that electrochemistry and what are the objectives are there in electrochemistry we are going to study. Okay, so electrochemistry, you know, electro means it is study of either the loss of electron or the gain of electron or change in chemical energy to electrical energy to chemical energy. That interchange, that study is called as electrochemistry. Okay, so it is the branch of chemistry which deals with the production of electricity from the spontaneous and non-spontaneous reactions. Okay, that is what electrochemistry. In this electrochemistry, so many topics are there. We often use electrodes, solvents, electrolytes. Okay, electrode potential, standard electrode potential, EMF means electromotive force. Everything we are often going to use in this electrochemistry chapter. The most important thing is the cell representation and cell reaction. Anode is there, cathode is there. In that anode and cathode, what type of reactions takes place and how they combine, how the reaction is written by combining anode reaction and cathode reaction. It's everything we are going to study in this chapter. Okay, what is the need to study electrochemistry? What is the application of electrochemistry? You know that, students, 1 gram gold you often learned. Okay, what is that 1 gram gold means? For a copper or any other metal, a gold layer is plated over the metals. Okay, silver plating, gold plating means exactly on the surface of the metals. So gold or silver is deposited. That is called as electroplating. So this electrochemistry has a vast application in the preparation of jewelry ornaments. Understand, for plating? Not only that, anything, any metal, if it is a single layer is placed over any other metal, that is because of applications of electrochemistry only. That is called as electroplating. Understand? So students, here, the as I told you, electrochemistry is the branch of chemistry which deals with the interconversion of chemical energy and electrical energy. Right here, deals with interconversion of electrical and chemical energy. So in this, two types are there. One is electrolytic cell, another one is galvanic cell. Listen. So the branch of chemistry which deals with the interconnection of electrical energy and chemical energy is called electrochemistry, and the device is called as electrochemical cell. Understand? And the device is called as electrochemical cell. Means the cell which converts or deals with the interconversion of electrical energy and chemical energy, either electrical to chemical or chemical to electrical. This electrochemical cell further classified into electrolytic cell and galvanic cell. Okay, so what is electrolytic cell means? So this is also called as voltaic cell. Okay, so what is electrolytic cell means? This one which converts electrical energy to chemical energy. One which converts electrical energy to chemical energy in spontaneous reaction. Spontaneous reaction. Okay, the cell which converts electrical energy into in non-spontaneous reaction. Not spontaneous. So the cell which converts electrical energy to chemical energy in non-spontaneous reaction. Obviously, the opposite of this is the galvanic cell. These which converts chemical energy to electrical energy in spontaneous reaction. In spontaneous reaction called as galvanic cell or voltaic cell. Understand? So listen, galvanometer, you know that which is to measure the electric current. Voltaic also which is to measure the voltage. But it is chemical energy to electrical energy. So two types of electrochemical cells are there. One is electrolyte, another one is galvanic or voltaic. Electrolytic means which converts chemical energy to electrical. Voltaic or galvanic means electrical energy. This one is electrical to chemical. This one is chemical to electrical. Understand? So students, in this galvanic cell means which converts the chemical energy to electrical energy. I am going to discuss with the main important cell is that is Daniel cell. Okay, we are going to discuss with the these are the terms. So what is electrolytic cell? What is galvanic cell? That is important for 1 mark. Okay. So in this, very important is Daniel cell. Daniel cell. So students, this Daniel cell, its construction, its construction is there, its working is there, and its reaction is there. Okay. So after construction of this, I'll explain what is electrode, what is electrolyte, and what is sulfates, everything. Okay. So listen here. What is the construction? To explain the terms used in that. So I write here what are the terms used. One used is electrodes, often used. In that electrodes, anode is there, cathode is there, right? Anode, cathode. Next, second one is salt bridge. Next, electrolyte. Next, electrode potential. Electrode potential. Next, EMF. Next, cell reaction. Last, cell representation. These are the terms we are going to discuss in each and every tip. What is electrodes, which one is anode, cathode, which one is cathode, salt bridge, electrolytes, electrode potential, EMF, cell reaction, and also this cell representation. Okay. So initially I will write the construction, later I will say the working, and after I will write the anode reaction, cathode reaction, and I will explain all those terms. Okay. So we will go with the construction first. Construction important for 2 marks. This is 2 or 3 marks. 2 marks or 3 marks. Okay. So students, in this construction here, two containers are there. In this, 2 rods are dipped. Two metallic rods. Okay. Here, this electrolyte is there. Means the solution, salt solution it is. Here also salt solution. Okay, so these are externally connected to a battery. Understand? Are in the right as fluctuation. Negation. These are externally connected to a battery or any external circuit. Next, and these are interconnected by a salt bridge. Okay, so in this salt bridge also solutions are there. In this salt bridge also solution are there, but that is a different solution. Okay, so students listen. For Daniel cell, it must be a zinc and copper. Excuse me. Here, the cells we are going to use is zinc and copper. So listen, this one is anode. Okay, this one is cathode. This is salt bridge. Okay, so students, this anode is made up of zinc. This cathode is made up of copper. Understand? And here listen, this is the electrolyte, that is salt solution of sudden SO4. Here the salt solution of CuSO4. This sudden SO4 and CuSO4 are called as electrolytes. Means salt solutions. Understand? So this is the arrangement of course, the arrangement of the Daniel cell. Daniel cell means it must be consist of cathode with zinc and copper electrode. So students here, left side is zinc electrode, right side is copper electrode. No, I am not telling like only left side zinc is present, only right side copper must be present. It is based on their electrode potential values. So in the chapter electrochemical series are there, later I will explain. So if the electrochemical series having positive value, plus value, standard electrode potential E naught. Okay, so if the E naught value is positive, okay, if the E naught value is positive and E naught value is negative, assume. So which one is more negative? That acts as anode. If the electrode potential is positive, then it acts as cathode. Repeating, standard electrode potential E naught value. If it is negative, then it is considered as an anode. If it is positive, then it is considered as cathode. So I will take two examples. For example, Ag plus is there, its E naught value is 0.80. Copper plus 2 is there, its value is 0.76 volt. Both are plus. Okay, I will take another one set. Same. Copper plus 2, its value is plus 0.76 volt. Okay, next. Zinc plus 2 value is minus 0.34 volt. Minus 0.34 volt. Okay. Sorry. This one is plus 34. This is minus 0.76 volt. Okay. So next, another one we take, another one set. Zinc plus 2, that is minus 0.76 volt. And another one is lithium plus 1, that is minus 3.02 volt. So students, here I wrote E naught value is positive, then it is cathode. E naught value is negative, then it is anode. So here, Among these two, which one is less positive, which one is more positive? Means this is positive value more. E naught value is more positive to this, less positive to this. So more positive means this one become cathode, this one become anode. Are you getting? So this one become cathode because greater positive value means cathode, greater negative value means anode. So among these two, this is less positive, this is more positive. So this is cathode, this is anode. Here, of course, it is plus, it is minus. So this one is anode, this one is cathode. Okay? Here, among these two, which one is less negative, which one is more negative? This is more negative, means less positive. Here, more negative. So this one, minus 0.76, less negative, means more positive. Then here, the zinc become here cathode, here it is anode. Are you understood? I am not telling, but zinc is always cathode, copper is, zinc is always anode, copper is always cathode. I am telling, so based on the E naught value, which one is more positive, then that is cathode, which one is less positive, that is anode. Or if you want to say, which one is more negative, that is anode, which is less negative, that is cathode. Here, more negative, anode, less negative, cathode. More positive, cathode, less negative, anode. Understand? So this is based on the E naught value, we can easily choose this anode and cathode arrangement. Are you getting? So this is called as electrochemical series, which is classified based on the electrode potential values. Later I will explain. But for you, I am telling there is no particular way to select. Sorry, not particular way. It is not necessary always that zinc must be an anode and copper must be cathode. Here is it. Here copper is anode. Here it is cathode. Based on the E naught. Only by comparison we can select which one is acts as anode, which one is acts as cathode. Okay? Listen. Next one. So this is all about construction, students. What about working? So how the construction? Listen. Two metal rods are taken. One is zinc, another one is copper, dipped in their respective solution. Means zinc is dipped in zinc sulfate solution, copper is dipped in copper sulfate solution. Means how to write? So zinc and copper electrodes are taken. Okay, such as anode and cathode respectively, which are dipped in their respective salt solution, zinc sulfate and copper sulfate solution. They are connected to the external circuit. Okay, and the electrolytes are interconnected between this salt bridge. Are interconnected by salt bridge. So this salt bridge consists of a solution KCl. Those are what? Non-reactive ions. K plus and Cl minus. They are non-reactive ions. Are you getting? So these are all non-reactive ions. They only just help to transfer electron from here to here. Understand? So these are never involved in the reaction, but they help to transfer electron from here to here. Understand? So students, next one what you want to understand is, when this salt bridge is connected in between the two electrolytes, then the system becomes closed. Understand? The system becomes closed. So when the closed system is happened, then the electrical energy takes place. Chemical energy is converted into this electrical energy. How? Here oxidation takes place. Here reduction takes place. Understand? Okay. So right here at anode, this is anode. Remember I explained what is anode. First I write. So at anode zinc is there. So zinc loses its electron and undergoes what? Oxidation. Zinc loses its electron and undergoes oxidation. Next, cathode. Here Cu plus 2 ions are there. This Cu plus 2 ions accept the electron of this and form Cu. The Cu plus 2 ions accepts 2 electrons from this thing and forms Cu. So gain of electron means reduction. Gain of electron means reduction. So remember always, at anode always oxidation takes place, at cathode always reduction takes place. Oxidation means loss of electron, reduction means gain of electrons. Remember another one is there. Always the anode is written in left side only, cathode is in right side. This is the systematic way. If left side any electrode is there, obviously that is anode and oxidation takes place there. If right side any electrode is there, obviously that is cathode and their reduction will take place. So students, overall reaction if you want to write. So anode reaction plus cathode reaction, that is overall cell reaction. Okay. So what is the cell reaction here? Listen, this two electron gets cancelled. These two gets cancelled. Remaining is what? Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Repeating, Zn plus Cu plus 2 changes to what? Zn plus 2 plus Cu. Here, from year to year, 2 electron loss is there is loss of electron, that is oxidation. From year to year, here oxidation state is 0, here plus 2, here plus 2 is 0 means 2 electrons is added. Gain of electron takes place, that means reduction. This is the overall cell reaction for daily cell. Are you getting? So what happens here is always anode is negative in charge. Why? Because electrons are released there. Oxidation state takes place there. That's why always anode is negative in state and this is positive state. Understand? Okay. So this is negative, this is positive. And remember, at cathode, cations are attracted. At anode, anions are attracted. Are you getting? Sorry. At anode, cations are attracted. Because negative charge is there, so cations are attracted or deposited. At cathode, positive charge means what happens? Anions are attracted. Opposite. Anions means negative. But anode is positive. That means what? Positive ions are attracted there. Are you getting? Okay. So this is all about what? I am telling students, overall this is negative in charge. Or if you want to say, right? So it is always negative, it is always positive. Okay? So and remember, here cell reaction is there, zinc, Cu plus 2 gives rise to Zn plus 2 plus Cu. So students remember, even though I am telling, this electrode initially it is positive in charge. After loss of electron, it becomes negative. Are you getting? Here loss of electron takes place, here gain of electron. So how the reaction takes place? Listen. This is the metal, zinc metal. This is the zinc solution. Here already Zn plus 2 ions. It is dissociated means what it forms? Zn plus 2 plus SO4 2 minus. This one plus Cu plus 2 plus SO4 2 minus. Correct? So in the both the cases SO4 2 minus is same. So the interchange of ions, the thing takes place. Here also 2 minus, here also 2 minus. And these two are same. Are you getting? So here, this is Zn. I wrote here, Zn is 0 oxidation state. Here Zn is 0 oxidation state. So the metal rod loses 2 electrons and forms so much Zn plus 2 ions. When after this what happens? The excess of electron takes place. The electron is more in this concentration. Then to maintain electrical neutrality means in both the electrolytes, electron must be same. That is electrical neutrality. To maintain electrical neutrality, these electrons are carried through this salt bridge to this solution. Understand? The electrons generated here through the ions in the salt bridge. Which are those ions? K plus and Cl minus. They carried through from this case here from zinc sulfate to copper sulfate. Here the electron increases. Okay. So here copper nothing involved. Here what involved? Cu plus 2 involved. Where is Cu plus 2 present? Here in this electrolyte. Correct? So the Cu plus 2 ions present this electrolyte accepts 2 electrons from this and they deposit it on cathode. Then the concentration of cathode increases. Here the concentration of cathode decreases. Understand? This is the mechanism of the reaction, how it works. Understand, students? So this is all about what? The Daniell cell and its cell representation and overall cell reaction. So another one is there, cell representation. Here I write cell representation. Okay, so what is the rule? Listen, first anode, solid bridge, cathode. How this anode will return? Metal and metal ion, solid bridge, metal ion and metal. So students, at anode, which is the zinc is there. Okay, so initially metal we have to write, that is zinc, followed by single slash, that represents what? Metal and metal ion. So metal ion is what here? Zn+2. Next, this double slash. Next, metal ion of what? Cathode. Which one is the metal ion of cathode here? That is Cu plus 2 or Cu. This is cell representation of Daniell cell, which is important for 1 mark. Very important for 1 mark. Always they used to ask, write the cell representation of Daniell cell. So students listen, these two tells about the electrolytes, electrode and the electrolyte. This is also electrolyte and the electrode. This single slash divides electrode and the electrolyte. This double slash tells about this salt bridge, means they are interconnected by salt bridge. Single slash means that tells about the relation between electrode and the electrolyte. This double slash means they are interconnected by a salt bridge. Okay, so I explained this electrodes, anode and cathode, salt bridge, electrolytes. Now I have to say electropotential and EMF. Cell reaction we did, cell representation we did. Initially only EMF and cell reactions. So I will take here, it is EMF. What is electrode potential? So students listen, electrode potential means, potential means what? Energy. Okay, so energy, correct, it's efficiency. So listen, when they are at a neutral state, when the system is closed, then the chemical reaction takes place. Okay, so students, here here zinc is there, zinc sulfate is there. In between these two, some force is there, force of attraction is there, energy is there. So from here also, copper is there, copper sulfate is there. So in a closed system, the potential developed between metal and metal solid, metallic solution or metallic salt solution of any metal. Understand? So the potential developed by metal and the salt solution of the metal Here, in between zinc and zinc sulfate, in between copper and copper sulfate. That is what potential. Just now I wrote. So listen. Here, the electron potential E naught for this zinc is, I told you, minus 0.76 volt. Correct? For this copper is plus 0.34 volt. Correct? This is called what? The potential, the energy developed. Okay? Here energy is liberated, plus shows. Sorry, plus shows means it requires, minus shows means it liberates. Means this prefers always the gain of loss of electron. This prefers always the gain of electron. Understand? Gain of electron means what? We have to add extra electron. We have to add extra electron means we need energy to add the electron. Loss of electron means it easily loses the electron to attain a stable configuration. So that is what E naught values here. The potential developed between zinc and zinc solution. Zn and Zn plus 2. Right? That is 0.764. So the general is, it is the potential developed between or interface between salt solution and the metal. So here also copper ion and the copper is 0.34 volt. Okay. Next, what is EMF? It is the potential difference between cathode and anode, two electrodes. So only the potential difference between, the potential developed in this zinc, developed in this copper is called as electrode potential. What is EMF? Electromotive force. It is the potential difference between this and this anode and cathode. Okay. So students, that is called as E cell. EMF of the cell. So E cell is always calculated as E cathode minus E anode. Why? Because students, as I told you, anode means which one has less negative charge. So more negative, less positive. So this one is more positive, less negative. More positive, less negative. Understood? More positive, less positive. More less negative, more negative. ಅಂದ್ರೆ ಇದು ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಮಾತ್ರ ಅದರಲ್ಲಿ ಕಡಿಮೆ ಪಾಸಿಟಿವ್ ಇರೋ ವ್ಯಾಲ್ಯೂನ ನಾವು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಇದು ಏನು ಬರುತ್ತೆ, ಪ್ಲಸ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ಈ ನಾಟ್ ಸೈಡ್. ಇಲ್ಲಿ ನೋಡಿ 5 minus 4 ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ, 1 ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾವು 4 minus 5 ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, -1 ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ರಾಂಗ್. Why this is always E cathode minus E anode means, just now I explained E cathode, which is more positive in electrode potential, plus value will connect. This is highly negative. So minus of minus is plus that. So listen, how to calculate E cell here, right? So E cathode is how much? Plus 0.34 volt minus of E anode is how much? Minus 0.76 volt. Just add here. Plus 0.34 volt plus minus into minus plus, right? Plus 0.76 volt. So here it is 0.76 plus 0. So that is 1.12. E cell. So listen, how to represent this cell? And right here, like this. What it is? Zinc bond. Like cell hierarchy. E Zn plus 2 bar Cu plus 2 is equal to 1.18. This is the way to represent the cell. This is the genesis. So So this is particularly for Daniell cell. Understand? So these are all the terms we are going to use in the electrochemistry. So students, this is about the construction, working, cell reaction, cell representation, of cell reaction, and also EMF calculation of Daniell cell, which is very important for 2 or 3 months. They may ask only construction, they may ask only cell representation, they may ask only of cell reaction, they may have told you to calculate this. Okay, this is very important for 1, 2, 3 months. ಯಾವ ತರ ಬೇಕಾದರೂ ಕೇಳಬಹುದು. ಅದಕ್ಕೆ ಎಲ್ಲನೂ ಒಂದರಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ವಾ? ಸೊ ಏನೇನಿದೆ ಇದರಲ್ಲಿ? So initially construction, and this is working, and that is calibration. Okay, so construction means what? So first ಎರಡು electrodes ನ ತಗೊಳ್ತೀವಿ, ಒಂದು zinc ಒಂದು copper, ಅದನ್ನ ಸೇಮ್ electrolytes ಅಲ್ಲಿ ಡಿಪ್ ಮಾಡ್ತೀವಿ salt solution. ಜಿಂಕ್ ಅನ್ನ ಜಿಂಕ್ ಸಲ್ಫೇಟ್ ಅಲ್ಲೇ ಡಿಪ್ ಮಾಡ್ತೀವಿ, ಕಾಪರ್ ನ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಅಲ್ಲೇ ಡಿಪ್ ಮಾಡ್ತೀವಿ. ಓಕೆನಾ? ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇವೆರಡರ ಮಧ್ಯ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ, ಮೀನ್ಸ್ ಎನರ್ಜಿ ಡೆವಲಪ್ ಆಗುತ್ತೆ. ಆ ಎನರ್ಜಿ ಏನಂತ ಕರಿತೀವಿ? ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ಈ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಇನ್ ಕ್ಲೋಸರ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಲೀಸ್ ಆಗೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಇದು ಜಿಂಕ್ ಇರೋದು ಆನೋಡ್ ಇರುತ್ತೆ, ಇದು ಕ್ಯಾಥೋಡ್ ಇರುತ್ತೆ. ಅರ್ಥ ಆಗಿದೆಯಲ್ವಾ? ಸೊ ದಿಸ್ ಇಸ್ ಆನೋಡ್, ದಿಸ್ ಇಸ್ ಕ್ಯಾಥೋಡ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇದು ಮೇಲ್ಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಲಿಸನ್, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಅಂತ ಬರ್ದಿದ್ದೀನಿ ಅಂದ್ರೆ ಆನೋಡ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಅಲ್ಲ ಅರ್ಥ. ಇಲ್ಲಿ ಅಯಾನ್ಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅಯಾನ್ಸ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರೋ ಸ್ಪೀಷೀಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಹೇಳಿ, ಇಲ್ಲಿ ಸಡನ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲಿಂದ ವಿಡ್ರಾ ಆಯ್ತು ಅಂದ್ರೆ ಇಲ್ಲೆಲ್ಲ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಡ್ರಾ ಆಯ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಇದೆ ಆಸ್ಕ್, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್, ನಾಟ್ ನೆಗೆಟಿವ್ ಇನ್ ಚಾರ್ಜ್. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಮೀನ್ಸ್ ಲೈಕ್ ಕ್ಯಾಥೋಡ್ and cathode, another name is negative electrode and positive electrode. But their charge is, cathode means minus charge, anode means plus charge. Remember, ionics group ನಲ್ಲಿ ಹೇಳ್ತಿರೋದ್ರಲ್ಲಿ another name. cathode ಅನ್ನು ಏನಾಗಿ ಕರೀಬಹುದು? ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಅಂತಾನೂ ಕರೀಬಹುದು. ಆನೋಡ್ ಅನ್ನು ಏನಾಗಿ ಕರೀಬಹುದು? ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಅಂತಾನೂ ಕರೀಬಹುದು. ಈ ಪಾಸಿಟಿವ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ ಅನ್ನೋದು ಇದರ ಚಾರ್ಜ್ ಅಲ್ಲ, ಜಸ್ಟ್ ಅದರ ನೇಮ್. ಚಾರ್ಜ್ ಏನಾಗಿರುತ್ತೆ? ಆನೋಡ್ ಅಂದ್ರೆ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ, ಕ್ಯಾಥೋಡ್ ಅಂದ್ರೆ ಮೈನಸ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಕ್ಯಾಟಯಾನ್ ಅಂದ್ರೆ ಏನು? ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ತಾನೆ, ಅದಕ್ಕೆ ಆಪೋಸಿಟ್. ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಇದು ಕ್ಯಾಥೋಡ್ ಆಗಿರ್ಬೇಕು ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಇರಬೇಕು ಅಂತ. ಅರ್ಥ ಆಗ್ತದೆ ಅಲ್ವಾ? ಸೊ ಈಗ ನೋಡಿ, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಆಗಿರೋದ್ರಿಂದ ಎಲ್ಲ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಬರೀತೇನೆ ಫಸ್ಟ್ ಇನ್ನೊಂದ್ಸಲ, ಮೈನಸ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಕರೆಕ್ಟಾ? ಸೊ ಇಲ್ಲಿ ಸಡನ್ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಡಿಮೆ ಇರೋದು ಏನಾಗುತ್ತೆ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಈ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಮೂಲಕ ಇಲ್ಲಿ ಪಾಸ್ ಆಗ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಕಲೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಎಕ್ಸಸ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಂಟೈನ್ ಮಾಡ್ಬೇಕಲ್ಲ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಇರೋ Cu+2 ಅಯಾನ್ಸ್, Cu+2 ಅಯಾನ್ಸ್ ಇಲ್ಲಿ ಹೋಗುತ್ತೆ. ಇಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿಕೊಂಡು ಇಲ್ಲಿ ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ. This is the way of working the electrochemical cell or a Daniell cell, which convert chemical energy into electrical energy. Example for a galvanic cell is a Daniell cell. So this is how the reaction takes place. The charge of anode is what? Negative. Charge of cathode is, sorry, charge of anode is positive. Charge of cathode is negative. So listen, ಇದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Cathode, electrode. Cath means cation. Cation ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಕ್ಯಾಥೋಡ್ ಅಂತೀವಿ. ಇದು ಪಾಸಿಟಿವ್ ಅಯಾನ್ ಇದ್ರೆ ಇಲ್ಲಿ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅದು ಮೈನಸ್ ಇರಬೇಕು. ಆನೋಡ್, ಓಕೆ, ದಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಆನೈನ್ಸ್ ಆರ್ ಅಟ್ರಾಕ್ಟೆಡ್ there. ಆನೈನ್ಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಮೈನಸ್ ಚಾರ್ಜ್ ಇರೋ ಸ್ಪೀಷೀಸ್ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಇರಬೇಕು. Anode charge is positive, cathode charge is negative. But cathode is called as positive electrode, anode is called as negative electron. Okay, na? So another one, if you want to remove from this, ಇದು ಶಾರ್ಟ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಇದೆಲ್ಲ ಇದರಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಎಲೆಕ್ಟ್ರೋಡ್ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್. What is the use of salt bridge? It helps us to transfer electron. It helps us to maintain electrical neutrality. It interconnects the two systems. Understand? It is a function of salt bridge. So next another two reactions are always at anode oxidation takes place, always at cathode reduction takes place. So either oxidation reduction process is the right. These two are half-cell reaction. Half-cell reaction ಅಂದ್ರೆ ಇಲ್ಲಿ ಯಾವ ತರ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಯಾವ ತರ ಆಗುತ್ತೆ. Complete cell reaction, overall cell ಅಲ್ಲಿ ಯಾವ ತರ ಆಗುತ್ತೆ. Okay, this one is cell representation. How to represent the cell? Initially anode means left side anode, salt bridge cathode. Anode ಮತ್ತೆ cathode ಅನ್ನು ಯಾವ ತರ ಬರೆದಿದ್ದೀವಿ? Metal ಅಲ್ಲ, salt bridge metal means metals are at the extreme left and extreme right. ಅದರ ಮಧ್ಯ ನಮಗೆ ಅಯಾನ್ಸ್ ಇರುತ್ತೆ. ಮೆಟಲ್ಸ್ Zn Cu ಎರಡು ಮೆಟಲ್ ತಾನೆ, ಅದು ಎಕ್ಸ್ಟ್ರೀಮ್ ರೈಟ್ ಮತ್ತೆ ಎಕ್ಸ್ಟ್ರೀಮ್ ಲೆಫ್ಟ್ ಇರುತ್ತೆ, ಮಧ್ಯದಲ್ಲಿ ಅಯಾನ್ಸ್ ಇರುತ್ತೆ, ಅದ್ರ ಮಧ್ಯ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ದ ವೇ ಟು ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಅದಾದ್ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ ಪೊಟೆನ್ಷಿಯಲ್. The potential which is developed by salt metal and a salt solution. So ಇದು EMF means potential difference between cathode and anode. Difference ಅಂತ cathode ಮತ್ತು anode ಅಲ್ಲಿರೋ difference ಅನ್ನು find out ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಎಷ್ಟು difference ಇದೆ. So the difference between the cathode and anode is called as electromagnetic force. Understand? So here the E cell of the radial cell is the to C in electron potential values substitute and the value. So the E cell of the radial cell is 1.1. So this is construction, working and calculation of the radial cell. So in the tomorrow's class we will discuss the construction, working of the SH. Okay, some examples are there, how to choose and how to represent them. This one is cell representation is important. Later giving some example for the electron next. Okay.